For today's video, we will answer a math challenge given by one of our followers. And the question goes like this. Solve for the integer value of x that satisfies this equation. X factorial equals 20 times x factorial raised to the power of 2. Now you can pause this video if you want to give this problem a try. And now, let's answer this question together. Alright, so our goal here is to solve for the integer value of x that satisfies this equation. X factorial equals 20 multiplied by x factorial raised to the power of 2. Now, to answer this question, what we're going to do is to notice this similar term. We have x factorial right over here on the left side, and we also have x factorial on the right hand side. So why not? Let's replace this with another variable, and let's call this as u. So now we can replace all x factorial with the variable u like this. And now let's focus on this equation. Now u factorial equals 20 times u squared. Now what is the definition of u factorial or n factorial? So n factorial, we can write this as n multiplied by n minus 1 factorial. So this u factorial, this can be written as u multiplied by u minus 1 factorial. Now how about u squared? So u squared is just u times u. Now we can now cancel out u on the left hand side and on the right hand side of our equation. So why not? Because u is not equal to 0. Alright. And then we notice that we have here u minus 1 factorial equals 20u. And now what we're going to do here is to subtract 20 and add 20. Now your question is, what is the reason of subtracting 20 and adding 20? Take note, this is just equal to 0. Alright, but if we factor out 20 and this 20u minus 20, we get u minus 1. And we have also u minus 1 on the left hand side of our equation. So that is the main reason. Now let's do that. Let's factor out 20. So this will give us 20 multiplied by u minus 1. Now let's subtract 20 times u minus 1 on both sides. So this will give us u minus 1 factorial minus 20 times u minus 1 equals 20. Now, applying again this property of factorial to this u minus 1 factorial. So this can be written as u minus 1 multiplied by u minus 2 factorial. Now, we can now get the common factor of u minus 1 for these two terms. If we do that, we get u minus 1 multiplied by u minus 2 factorial minus 20 equals 20. Alright. Now, take note that x is an integer. So now, and also u is an integer, of course. If x is an integer, then u must be also an integer. Now, since it is equal to an integer, so why not get the factors of 20? Now, the factors of 20, we have 20 times 1 or 1 times 20, and 10 times 2 or 2 times 10, or it can be 5 times 4 or 4 times 5. Alright, now, let's have the case that what if this is 20 and this is 1? Alright, so this is multiply. Now, if u is 20, or if u minus 1 equals 20, then u equals 21, and that is a big number. So, this case is definitely not possible for us. Even though this factor is 1 and the other one is 20, then u minus 1 seems too small. So we get u equals 2, then 2 minus 2, this will give us a value of 20. Alright? So this factor is not possible. Now, how about 10 times 2? So what if this u minus 1 is 10 and the other factor is 2? Now, if u minus 1 equals 10, then u must be equal to 11. And 11 minus 2, this is just 9 factorial, and that's too big. And if this factor u minus 1 is 2 and the other factor is 10, u minus 1 is equal to 2, so u must be equal to 3. Then 3 minus 2, this is equal to 1 factorial, and 1 factorial seems too small, so this factor must be also not possible. So the only left must be equal to 4 times 5 or 5 times 4. So we have two possible cases here. So we have 5 times 4 or 4 times 5. This u minus 1 can be 5, or this can be equal to 4. So this is our two cases. Alright, so let's do that. Now, let's have this second case. So what if u minus 1 equals 4? So this is equal to 4, so the other factor must be equal to 5. Alright, now let's solve for the value of u. Let's add 1 on both sides. So u must be equal to 4 plus 1, and 4 plus 1, this will give us 5. Now let's check if the other factor must be equal to 5. So u minus 2 factorial minus 20 equals 5. So let's check. If we replace this u with 5, this will give us 5 minus 2 factorial minus 20 equals 5. Now 5 minus 2, this will give us 3. And we know 3 factorial, this equal to 6, because 3 times 2 times 1. Now 6 minus 20, this will give us negative 14. And we know negative 14 is not equal to 5. Therefore, this case is also not possible. So now let's move on to the first case. Alright, so what if u minus 1 equals 5 and u minus 2 factorial minus 20 must be equal to 4? So let's do that. So u minus 1 equals 5. Let's solve for the value of u. Add 1 on both sides. 5 plus 1, this will give us 6. Now let's check. If u minus 2 factorial minus 20 must be equal to 4. Now let's substitute the value of u. What will happen if this u becomes 6? 6 minus 2, this will give us 4. And 4 factorial, we have 4 times 3 times 2 times 1. This will give us 24. And 24 minus 20, this will give us 4. And we know that 4 must be equal to 4. Therefore, this case is okay. So we can say that u must be equal to 6. And take note that u must be equal to x factorial. So we can say that x factorial must be equal to 6. And 6 is equal to 3 times 2 times 1. And 3 times 2 times 1, this can be written as 3 factorial. So we can say that x must be equal to 3. And that is the only answer to this question. Therefore, given this equation, x factorial equals 20 times x factorial raised to the power of 2, then the only integer value of x that satisfies this condition must be equal to 3. And as always, we are done.